Добрый день, уважаемые.
Good afternoon, esteemed ladies and gentlemen. Let me welcome you at the round table, which is called Digital Twins Rule, Railways Digital Twins, from Theory to Practice. My name is Mr. Miskaryan. I'm Director General of Modern Technology as a joint stock company. And let me introduce to you our speakers. Yevgeny Charkin, Deputy Director General of the Russian Railways. Denis Simakin, Director General of Modern Radio Technologies. Good afternoon. Yevgeny Shmelev, Director General of INSPARK. Good afternoon. Dmitry Krasilov from Supply Chain Design of KORUS Consulting. Good afternoon. And Denis, Director General, Synthesis AT Joint Stock Company. Konstantin Boltrukevich, Head of the System Integration Department. Online with us is Jean-Michel Evangelo, Deputy Director of the International Railways Systems from UIC. So the meeting is quorate. Digital twins for railway transport. First of all, I'd like to say that digital twins surround us in our everyday life, and we may not notice that. For instance, Yandex Maps are integrated with the traffic jams map and are very helpful to get to your destination point. And anyway, these maps act as the digital twin of the road map, and simulation of the traffic helps you to reach the destination faster, whether you travel on foot or by car. The company's budget is a digital twin of its economy, which helps to predict the behavior of the company in different circumstances, to plan its activity and to take necessary decisions, bearing in mind certain factors which may affect its work. The cost accounting during the construction, even if it is done on paper, is also a digital twin of certain facility, which is done with accuracy that helps to build that structure, that facility with all the design features. Speaking about the digital twins, any model, any simulation is a digital twin or a copy of an object. But this helps you to do that cheaper, faster, more efficient with a lot of input data, therefore bringing down the costs of the operation, improve your cost efficiency, your revenue, etc. Railway network is one of the most sophisticated pieces of infrastructure, which is made up of the physical infrastructure and also the rolling stock, automation, the power grid, and other elements. And we cannot overestimate the importance of simulation for railway transport, bearing in mind the volume of operational costs and the objectives and challenges relate to bring down the costs, improving the operational efficiency. Therefore, digital twins for railways is very relevant. And I'm passing the floor to Mr. Charkin, who will speak about the ecosystem of how we operate the facilities and objects in the Russian railways. Thank you so much, Alexander. Good afternoon, dear colleagues. I'm glad to welcome all of you at our offline event, which we were looking forward to. Thank you so much for your time. Probably lots of you heard that last week we managed to approve our strategy for digital transformation, and next step would be approval by the board of directors. One of parts and parcels of that strategy is about the effect which we're going to gain. Every project, every platform is digitalized in terms of the effect that we expect to get. And these effects are related to the long-term development program. A major part of the effects that we expect under that strategy are associated with building and further successful operation of digital twins of our infrastructure. In essence, digital twin of infrastructure fits very well with the global trend. It allows, at the stage of construction, to improve the operation efficiency for certain pieces of infrastructure in different industries. And also, the best practices stand for BIM factors or digital modeling or simulation during the construction. And among the best practices, you may bring down the costs, improve the speed of designing, and cutting the timeline for the construction. We have prepared our benchmarking, which was done this year. In every detail, we studied the technologies, and we took a decision that we're going to develop our own ecosystem of running the life cycle of the objects and pieces of infrastructure. We purposefully decided that we will not focus on some separate processes which sometimes takes place in the world. For us, the overall efficiency is important, the efficiency of the whole life cycle. The key effects and the key factors which we aspire to achieve and which integrated into our strategy is bringing down the losses, and we aim at streamlining the interaction between all the stakeholders of the ecosystem within the company and with our contractors. Another thing which is quite important, we will streamline our relations with the public agencies during the life cycle of our construction process. It will improve the accuracy of planning. For us, it means or stands for the terms and timeline. It will help us to cut costs of operation. This is what I mentioned before. And certainly, having the database for the digital twin, we can promptly react to different abnormal situations, and as a result, we will reduce the number of accidents or incidences or failures typical of the work of the infrastructure. In that area, we have 3 systems to develop. Single corporate platform, which helps work with the technical documentation, which is called EKP. TD on the slide, the BIM strategy and digital twin. These are the 3 factors. Single corporate system of managing the technical documentation covers all the objectives in terms of maintaining and supervising the technological decisions and solutions. And it saves up time, and time means money for all of us, so this is our asset. This way we'll cut time to do the routine operations. And at the same time, we are managing the project and construction, project designing and construction based on the digital simulation. Digital twin also will help to control the business processes during the operation. So all these 3 systems will make up an ecosystem, helping us to dramatically improve the efficiency of the whole life cycle of the capital construction facilities and objects. Any object, any facility at any stage of its life cycle will be integrated into our digital twin. The life cycle starts from the construction, and the manufacturer makes a digital twin of that object, which will go through the designing process and BIM system, and will end up in the digital twin at every stage. This model, this simulation, will be complemented with certain data. Later on, we arrange a connection between the simulation between the digital twin and the real object, thus obtaining the real-time information about the object and the infrastructure. Therefore, we can properly react to any abnormal situations and incidences. This end-to-end process works in a more agreed or consolidated way. One of the most important results for us in terms of how this ecosystem is going to function is that we can proceed from servicing our, we can maintain our infrastructure based on its conditions. Therefore, we can reduce losses, cut costs for all the stakeholders of this end-to-end process. That's a very busy slide, but really it shows the scale of what we embarked on. This ecosystem integrates all the stakeholders, both within the company and the contractors, and every stakeholder has its own digital portal, the customer's portal, the portal of the designing organization, construction organization, and of the operator. We have developed a role model which helps all the stakeholders of this end-to-end process to get access to the piece of data that they really need. For instance, Expert Organization Portal provides access to the data models we're working with. Our partners from the expert analysis or institution or Gosexpertiza. We provide access to the data about our digital model. Experts may provide necessary comments and feedback, and as a result, we can reduce dramatically the time taken to obtain necessary permits from the expert organizations, and as a result, we actually improve the efficiency, reduce timeline, and everyone actually brings down the costs once they use digital tools and instruments. Our ecosystem brings together all the stakeholders of that process, and the whole system becomes very transparent. We see that design and construction takes much less time, which is very important. Bear in mind very ambitious goals which we put forward in terms of building and maintaining our infrastructure. We reduce the chances of failures of our technologies and equipment. I do think that my colleagues will go into more details, shedding some light on the technological aspects of what I've mentioned. Therefore, in brief, I told you what we are doing, and thank you so much for your attention. Thank you, Yevgeny Charkin. Our next speaker here actually later on will discuss in more detail the systems, so we'll talk to the developers, the ones who are going to take the floor. Let us move forward. Russian Railways play a leading role in the UIC. Next year, the UIC will celebrate its 100th anniversary. UIC is made of more than 100 railway companies from almost 100 countries. UIC aspires to improve the competitiveness of railway transport as a system which provides certain services. It aims at spreading the best practices in terms of simulation, etc., etc. So the UIC accumulated large-scale experience. And I'm passing the floor to Deputy Director of Railway Systems Department of the UIC, Jean-Michel Evangelo. Over to you.
Hello, thank you very much. You can hear me well, yes? Thank you very much. It's a privilege to be with you today with such interesting and and a high-level audience. I will try to speak about the activities we are doing in UIC regarding digital modeling and digital twinning. Of course, I can only agree and support strongly all what has been said by the different speakers before. This is exactly the philosophy we are sharing in terms of evolution of a description of the railway system in its role, with this very big complexity, as you mentioned. And I have to say that we consider in UIC digital twin and digital modeling as a key milestone for the digitalization of the railway, which is going to happen in all the region of the world, in Russia, but also in Asia and also in Europe and other continents. So and we really consider that the transformation of railways, for all what has been said before, and the description of assets, the simulation, what we call the formal methodology of describing the functional aspect of the railway system, they need for that a tooling and a framework, which is called generically the digital modeling or the digital twin, and we absolutely need to, I mean, the railway sector in its role to progress on all this aspect, and we will save costs. We will have more efficiency, as it was mentioned. Could you put? I have some slides, so if we can take these slides very rapidly on screen. Yes, next one. So I mentioned in UIC there was initiatives in some years. We have developed some specific initiative in digital modeling since a couple of years, since 2014 to be exact. One of them, we call it RSM, Rail System Model. So Rail System Model is, if you want, a generic and generalist system model for the description of the railway system in its role. But its particularity, it's a bit complex to explain, so I will try, but its particularity is that it will act, and is acting today, yet, as a backbone to receive more specific descriptive language, because one of the difficulties of the world of modeling and digital twin is that you had in the world and in the railway sector different initiative of description of objects, depending on the way you want to describe it, from an angle from a dimension of a functionality, from a dimension of a construction like beam, or from another angle like geographical aspect. And so the difficulty is to make all this model work together. And RSM, Rail System Model, has been conceived in order to give a sort of backbone, a sort of glue, of aggregator of all this existing system model. So it's a sort of translator and capable to aggregate and capable to interact between all these different description models. So it's quite a complex thing, because it's not far from mathematical things and mathematical description, to be honest. But we think it was a very good point to develop, and we are now at a point which is quite advanced, and we are happy. And I will very quickly show you what I'm speaking about. I think we have been making progress this last years on that, and we see something solid coming. The second initiative I want to highlight is called OntoRail. OntoRail is meaning ontology for rail, because when you are speaking of digital twin, you are very frequently coming to the wording of ontology, because at the end of the day, the way you describe a system is a sort of language, and a language is an ontology with a grammar. And so what we wanted, in order to follow the objective to have an aggregation, a consolidation, a convergence between initiatives existing in the domain of digital twin, we needed to have a specific tool capable to compare, capable to visualize first all these ontologies, existing ontologies, because there are several of them. We needed to have a tool capable to compare them, and to at the end to be capable to mix with some relationship between objects of different worlds, to mix them in order to have if you want, a meta language capable to understand every single object defined in a given set of digital twin. So that's the second initiative on Rail. Next slide, please. So as I said, just you look at the right part of the slide, which is the interesting one. There are different ontologies on different system models existing today in the world, in the railway sector. You've got one which is quite well known all across the world because a lot of countries, all continents are working on it. It's called the IFC rail. It's describing quite a lot of objects. However, his angle of description is really focused on the assets. I mean, on the construction. It's really a beam vision. It's you describing objects like describing assets in a global network. You've got another one, for example, which is ULinks. ULinks is a signaling focused ontology. And ULinks, for example, has developed models where you have a formal methods and simulation of functional aspect of the signaling of railways. But it's not the same that IFC rail, because IFC rail describe a signal like a construction, if you want, like a very simple thing. But ULinks will describe a signal with the functions. And the problem is that railways are using models from IFC and models from ULinks. And that at a moment of time, you need all these models to converge. And that's the role I was describing for RSM. And we have good example today where we are mixing the construction view of IFC with the functional view of ULinks. Well, you have other things on the left part of the slide. You will see the different aspect of the digital twin, because at the beginning, digital twin, everybody considered the beam aspect, which is what I simplify by construction vision. But coming forward, and it was said by the speakers before me, it's very important to consider also the functional view, the logical view, the spatial view, the statistical view, everything, and the simulation at the end. So all these aspects are different, and that's where you will need this mix of ontologies and system. Next, please. Next slide, please. So RSM, just a point on this one. We are today at the RSM version 1.2 that we had a new release this year, which is integrating topology management, network management, location management, positioning, observation, and measure, which are new modules we have put this year in this system. And as I said, a system capable to interconnect with existing selected ontologies already defined largely since some years. What's next? Increasing the convergence with new modeling initiative and use OnTorel in order to increase the automatic production of I would say of UML and informatic aspect. So that will be there is all a plan for RSM to go forward, and it's now quite a solid system existing. Next slide, please. OnTorel, as I said, OnTorel is a knowledge engine where you put inside different ontologies. For example, ULinks, I was speaking about, IFC, but also the one of the European railway agency, which is listing all the track description in political Europe. So OnTorel is a sort of a semantic dictionary, an encyclopedia, which is capable to consolidate and to read any of these models. And after that, to compare the object between this model, and then to open the door to create object or to create new classes that will permit to link and make all these things interact together. So that's really the global. It's difficult to explain again, but the real objective is the convergence of years and years of work done by thousands and thousands of people, and not to redo everything, but trying to get what has been done, which is interesting, and to make it work together. Next slide, please. So you've got here just a very easy example of what is OnToRail. OnToRail is at the end of the day, it's an application. OnToRail is an application where you see here in a page, you see 6 different ontology. You see Ulinks, you see IFC, you see, for example, another one I didn't speak about, which is transmodel. Transmodel is an ontology based on multimodality, which has been developed for multimodality for train, but also for other kind of mobility. And X2Rail is something which is more on automation, ATO, this sort of thing. And so OnToRail will permit to have access to all these ontologies to look at all the classes, the organization, the aspects, the objects, the links, the properties, everything. And after to make comparison between them. It's a tool of visualization, of education, and also of comparison, and then of decision to create new interconnection between models. Next slide, please, and I will finish with that one. You've got a very small example and very simple. I didn't want to make a complex screenshot and capture of screen. You've got here a very small description of a kind of class which is read into OnToRail. In that case, it is a class from RSM, because RSM is by itself also a system language. Even if it is a backbone for the rest, it is also a proper system. So really, and I will finish with that, the ambition of UIC on this topic is clearly to facilitate, to push, to try to take all the initiative or all the major initiative that existing today in terms of description of digital twin in the railway system, and trying to consolidate them and to aggregate them in a sole system that will be quite unique at the end, because again, it's years and years and thousands of people that have been working on that on the last 10 to 15 years. So it's an incredible work that we absolutely need to consolidate on. Thank you very much for your attention. I hope it was sufficiently clear, because it's not, again, it's not an easy subject to describe.
Thank you, Mr. Yevgeny. I have a question. Maybe you are the person to provide an answer to that question. In which country or in which of the rail companies do you think you may find the best implementation, or the fastest implementation of the concept of a digital twin? So which country or which company is the pioneer there, or leader?
I don't know. I don't know in detail every country in the world on this aspect. I know some of them. For example, I'm sorry to say, and maybe that will be the opportunity to do it in the future. I don't know exactly what is doing Russian Railways in that domain. So I will not speak of Russian Railways. You have a lot of people to speak of that today. I will speak of other countries. I think China Railway is quite well advanced in that domain, particularly in construction. They have been very active in the definition of the IFC rail I was speaking about, and their industry also. I mean, the manufacturers are very linked to that domain, because at the end of the day, it's a global system for everybody, for the railways and the manufacturers. So China, I will give as an example. If I'm looking to Europe, I think the countries which are the most advanced today are probably my personal country, and it's not because I'm French, but it's SNCF in that case. But also Deutsche Bahn is quite well. Maybe they have been a bit late for a while, but they have been putting a lot of efforts on that, and a lot of investment. So and more generally, a lot of countries in Europe are now understanding it's a major step and milestone for digitalization, and so cost efficiency and this sort of thing you have been speaking about. So I would say the big ones today for me are China, France, I have France and Germany, but the others are starting to do very good things as well. Okay, but what is interesting in these companies, and that's why I'm highlighted them, they have been introducing the digital twin in their internal process. So now it's a fact. It's completely some of their operation and some of their action are completely embedded with the digital twin. That's where they are quite advanced in my mind. But again, I'm sorry not to speak of all the countries because I cannot say I know everything everywhere. But
Спасибо. Спасибо, господин Ангелу.
Well, thank you very much, Mr. Evangelou. I hope that you will stay with us until the end of our roundtable and you will have a better idea about what is going on in Russia. And of course, at any comfortable time, we can share with you additionally some information about what is going on here in Russia. We all understand that a digital twin is not possible without any real-time data coming in and used as input. And at the early stages of digital twins, you would usually manually put in data, but in the end of the day, we would usually come to using various gauges and signals. And of course, a company, which is very important for many industries of Russia, providing IT platforms, and having over 300,000 various signaling equipment in its pool. Now let me give the floor to the person who will be talking about the production of the protocols of signals. Well, we are the producer of this Class LP1 Russian protocol of data transmission, and of course we can then implement the services that I'm going to talk about. Well, when we are building a digital twin and we need to use data from different and heterogeneous sources, and not always it is possible to consolidate those inputs. When we were developing our own protocol, we wanted to make sure that our ecosystem will provide a fast and high-quality approach and consolidation and integration of data at a good speed. Well, we actually had a fundamental vision of what we need to do. And we followed the way of creating our own protocol. And this protocol has been implemented, as Alexander said, that our system makes it possible to receive data from over 300,000 signaling equipment on a daily basis, and the number is growing. Now, most of the devices connected to our system are actually using the ecosystem that we have developed. Regarding the digital twin, we can see that we can really provide for a high quality and fast and efficient deployment of this solution and get the advantages of such real-time information, almost real-time information using radio channels. And the efficiency there is that we can create the number of gauges, very high number of gauges per square meter. Sometimes it is very important for railroads. For example, if you take a kilometer of railways and you would use some cables, it would not be efficient. So you need to have some wireless technologies. So to transmit data into a distance of 1 kilometer, 10 kilometers, is something that we can already implement, and we already have some examples of the real projects that we have done with Russian rail. I should also say here that to us as an ecosystem, this source of data is not really important. We can integrate all those different sources of data and inputs, and by creating this protocol, we wanted to have it as a universal protocol to cover all inputs. Importantly, when we're doing that, we are actually providing the full tool set to the institution that is going to produce a device. For example, if you want to have a temperature gauge, then we would be providing the vendor with the full algorithm of development, and then it can be integrated into the gauge. And of course, from the idea to the implementation, it takes not years, but only several months then. And of course, time is of importance, and sometimes you need to act quickly to get data right here and right now. And we actually tried in our protocol to offer various protection and security mechanisms, which is important for the railroad infrastructure. And we also introduced some QC and QA tools into our protocol so that people would be assured in the quality of the solutions. And of course, the channel is two-way, and you can get also kind of like a control or management channel if you need it. Well, the application there is quite broad, and we started off with some elementary services that were implemented in the utilities sector. Now we have such a comprehensive projects that we are not really limited by the dreams of our customers, and we already have projects where clients already at the phase of integration can add some additional functionality and get some unique systems. And this is all possible thanks to the, and always in line with the strategy of Russian railroads, and where you can get data as needed and when needed. Well, that was briefly from my side, and Alexander, over to you. Thank you, Denis, and indeed, can you somehow estimate the need of Russian railways in such data, and how much, what is really the scale of the development of new solutions, and those new solutions, just how much of those are needed, and those existing gauges, can they cover the future needs? As I mentioned before, fundamentally speaking, everything is ready. On our end, for example, if you take the radio channels and the links, but also fundamentally, everything is ready in terms of the devices and gauges that can transmit data and collect data or measure something. All you need now would be applied research. That would be required at the moment of deployment, and we're talking about different time scale there. So the market is ready for the deployment of such solutions indeed. Well, colleagues, indeed we understand that a lot of data which are required for some full-fledged deployment of the digital twin would require millions of gauges to be employed. And a minimum is like 2 million gauges and devices that would be providing input data, and those gauges will need to be controlled and operated and maintained, and for that we need some solutions of and technological monitoring. And we have with us Alexey Shmelev, the CEO of INSPARK, who will be sharing with us information about such a platform. I actually thought of my mission differently. I would rather talk about the Internet of Things, IoT, and probably not many people understand what it is, really. I don't think that there are many people who can provide a very clear description and answer to what is IoT. This is not a technology, this is a concept, which is close to the technology. It's a very young technology, or eternally young technology. It all started with RFID tracers and the idea that they need to communicate with each other. Now it all has grown into some cloud computing and various program-based networks, big data, VR analytics and machine learning, all of that is part of the IoT, or the part of the set of technologies that IoT is based on. And of course, from this point of view, indeed, it has very good vistas, and probably in 20 years or so, somebody here would be again discussing the very notion of the IoT, but using some different terminology and visions of that.
К чему это все? К тому, что интернет...
What is this all about? Because IoT, this is about everything, starting from gas consumption, microclimate, load-bearing structures, digitalizing all these things. What today is so important for the digital model or simulation in terms of understanding not just statistical data, but in terms of what features and parameters or what deviations can be noticed in this or that facility or object. There is another peculiarity. This is the infrastructural manner. IoT, this is not about the most important things. This is not about things which are being automated. IoT, this is about the rest. And the rest, usually, that's the infrastructure. And railway consists of the infrastructure. And it is the infrastructure, paradoxically, or ironically for the railway. The use of IoT technologies is mandatory. And why digital twins should operate the IoT just in order to bring in life the digital twin. Otherwise, it would be just a template, set of documents which would describe some statistic data. In order to revive it, to resuscitate it, we have to bring in the updated information, visualize it, making it live. After we aggregate and bring together the statistical data and static data and dynamic data, we'll have a live simulation which will run the asset. If the technology allows to change something in the template or in the maquette, then we will get a live feedback. Only then all these effects could be made possible. Starting from cutting non-production costs, such as once you leave the room, you have to switch off the light. You don't have to consume so much energy. Take care of the climate. Also, the failure rate has to go down, and the analytical data is very much helpful. And once this digitalization incorporates a human factor, it will improve the HSE standards when we know where the person is, whether he's approaching a hazardous area, how he feels, if he's wearing PPEs. And certainly it improves the convenience and comfort rate for the passengers once we speak about digitalization of habitated spaces where our clients may be. We may just manage the climate factors at the terminal stations, thus just not only saving up energy and power, but also improving loyalty. A person who breathes well, who can intake enough oxygen with no headaches, and this is going on with us. The people who are having shortage of oxygen, they'd rather move away either home or into the street. These are not the most loyal clients. You may just control the microclimate and other things. And most importantly, what the digital twin will give you, based on the IoT, you may improve the efficiency of the business processes. Once you have digitalized your infrastructure, the personnel who is involved in the operation of that infrastructure sees in the same unified or single digital space all the assets they have to manage, they have to control. If they see instantly all the deviations, if they remotely can make diagnosis, they no longer have to come to the infrastructure in order to remedy something. And such a remote settings helps to do some ranking or ranging in terms of the high-quality personnel, meaning that well-trained or high-competent workforce do not have to go to the field. They can do that elsewhere. And for instance, the field trips or the field inspection or visual inspection actually would be needed only once they instructed to do so. The full digital twins are alive, and they can become live only once you use IoT. Alexey, tell us a few words about the platform which we have developed and whether it is different from the overseas solutions. I'm taking that question with pleasure because this is very close to my heart. Thank you for advertisement. Okay. INSPARK IoT platform is really unique in the market. In brief, what makes us different from the rest of the advanced solutions, including the foreign ones, we are a complete functional platform. Fully functional means that you have software at the lower level, the controllers and meters, and ending with the interface, user's interface. Secondly, our platform includes the steering and control using HE components. So these are the same cross-border computation. And we offer the out-of-box solution. It can boast scalability, cloud computation, and you may work with different installations. So it means that we can be installed at the local infrastructure of a client, or we can work in the clouds of the providers with all the state-of-the-art technologies of balancing and tuning. And end of the day, this is about the scalability of the solution. Denis said it may take weeks, but really it may take just days. There are a lot of cases that deployment and installation from the idea to the full implementation took just several days, and this would be just large-scale objects. We actually didn't see any counterparts, anything like that. The West would use SCADA systems, and in order to proceed to the IoT system, they have to do the full restructuring. They just did the rebranding or renaming. So they did some patchwork. And the second biggest IoT systems in the West, this is a set of tools in the cloud resources. In the first case, you can build a solution, but it would be expensive and not scalable. But in the second case, actually, it would be scalable, but it would take a lot of time, several years. And our solution doesn't require any further R&D, and it takes us several days. Just to confirm what I've said, Huawei, and I do agree that China can boast the biggest number of digital twins. As a phenomenon, as a process, Huawei, as a technological company, selected Smart Campus for its products. And Smart Campus, this is us. And we were benchmarked against the world giant, and we were selected as such. And now we are agreeing on becoming the exclusive provider. Thank you so much. That's great that import substitution helps to develop such solutions. We spoke about the ideology, the philosophy. We spoke about functionality. We spoke about meters, IoT as such, and the aggregating platform. Bring together all the meters. And next step is to discuss what is going on with the services which are being used for designing operation with the use of digital twins or digital models. Saying that, I'm passing the floor to Denis, the developer of certain solutions. Good afternoon, dear colleagues. I'd like to show to you certain elements and specific features of the systems which were highlighted by Yevgeny, Charkin, and which give the effects which were shared by other panelists, by the other colleagues. Let me tell you about the technologies which are being used at the Russian railways. I will show a number of videos which will help you to get a glimpse of such solutions. May we see my video? That's a unified system of maintaining documentation. That's an editor which brings together all the elements typical of the railways, different functions of automation, using templates in order to build other templates. The end purpose is to cut costs for automation, and the second objective is to synthesize digital twins. The railway technologies are lengthy, and automation and synthesis of digital twins should be done quickly. Therefore, the number of input data should be limited. And we have to automate the synthesis of the digital twin. In order to do that, we have installed such a database, different templates, layouts, etc. After you save it up, this layout may act as an electronic model. May we show next video? And you may use that electronic model in order to obtain a digital twin of a railway. And now you will see how it looks like. I'd like to stress once again the difference from other technologies. This digital twin is automatically done following the design documents, and it doesn't have to analyze the cloud of dots. This is how the digital twin looks like. So we made a 3D model. Data systems were incorporated, and the failures are visualized as bubbles, and we obtain the data from different diagnosis systems, DMI system, other models. There are predictive analytics models which are being developed by different developers, including us, and they are helpful to predict the failures and outages which may occur. Such a bubble pops up, that's a failure, then an instruction to the mechanical engineer has been developed, and the bubble disappears. Then the failures have been identified, and the trains are not delayed, and insofar it gives certain economic effect. This is done at the stage of operation. Next video helps us to proceed with the construction part. So digital twin gets the data not only from the single platform, not from only the diagnostic systems, but also from the beam system. Russian Railways develops its own beam system, which consists of the two main parts. So the administrative part, which maintains all the business processes. We see the planning process. Certain roles are being assigned to the stakeholders, and after that, we keep track of the whole business process. We identify bottlenecks, and etc., etc. Second part, that's the work with the beam model. The technology of information model implies availability of 3D models with certain parameters. You have to do expert analysis, and at the end of the day, it has to become an operational model. There are certain subsystems of how you work with that beam model. In order to do that expert analysis, you submit to the expert organization certain mistakes which were identified, you get another beam model, and at the end of the day, you get the model which then would be handed over to the constructors. Next video is about import substitution and designing. At the moment, we're using Western solutions, but we are making our own homemade systems, and this is an import substitution AutoCAD. You can use that in order to do modeling just like you do that in CAD. Not to miss anything, you can open any templates, any layouts and drawings, and introduce certain changes. All these systems build one single contour in order to service the whole life cycle. That was in a nutshell what I had to tell you. Well, there are lots of BIM solutions, in particular the ones which are not import substituted. And what you suggest, is it different for the better or for the worse? Well, actually, there are two main peculiarities. We immediately decided that it should be a web-based solution, that you don't have to have lots of software. Just you log in, type in your password, and that's it. Apart from working with 3D, we are doing a full-fledged work. We control the whole business process. We control all the stakeholders of this process. And also we look for the bottlenecks. We focus on that. That's the main difference between the BIM system and other systems. Well, really, that's a unique difference, because mainly all the systems are 3D based. Well, no one is focusing on the processes, unlike you. Understand that you have other events to attend to. Well, I have to excuse myself, and thank you so much for your participation. I think that the presentations were very much interesting. Hope they were useful. Thank you so much. Thank you, Jean-Michel, for your international experience. I hope, dear colleagues, that again you got something interesting, something fruitful. We all are from one and very interesting industry. I hope that the presentations were inspirational. Thank you so much. We'll get back to the digital twins and infrastructure. At the same time, we understand that digital twins and infrastructure have to provide for transportation. We understand that there are global digital twins of supply chains, and colleagues will tell us about that. And railway is part of that supply chain. We understand that the models, just like nesting dolls, there is a simulation or model of a station. There is a model of trains, how they go through those stations. There is a model of commercial transportation of passenger or cargo trains. Just this is for you to understand the nature of these models. I'm passing the floor to Dmitry Krasilov from KORUS Consulting, who will tell us about the simulation of supply chains for railways. Colleagues, good afternoon. Thank you so much. My name is Dmitry Krasilov. I'm from KORUS Consulting Company. Online with us is Alexander Semyonov, Director General of our company. Thank you so much for inviting us to take the floor. Today we are discussing a very important topic of digital twins, which are being used for supply chains. That's a very multifaceted, multi-dimensional topic, and we have our own view as to what a digital twin is about, especially the one which is used for supply chains. This topic is covered very well by other industries. KORUS Consulting pays a lot of attention to the applied mathematical modeling, and at the moment we have created 23 digital twins for different companies from a number of industries. Today we're going to tell you about one applied aspect of using digital twins, how digital twins for supply chains may help you to take decisions for investing into the logistics and its infrastructure. And actually we differ a lot in terms of understanding what it is.
And let me try to demonstrate something that I meant, and it works. So digital twins can be different, and they can provide different solutions to different tasks. And even today, during the presentations, we have already heard some of the opinions that may complement each other, but may also be different. The main value of creating digital twins would be the creation of a risk-free environment for any subsequent scenario-based analysis. In particular, when we're talking about digital twins, when the colleagues are talking about digital twins and in literature, what is meant mathematically by digital twins would be a simulation mathematical model which provides a very detailed description of various processes like the IoT, many gauges to be used, etc. It all fits. However, when we try to extrapolate this notion to the logistical concepts, it means that we may use the digital twin to find some bottlenecks in the logistical chains. However, life is more multifaceted and complex, and you can see that the digital twin can provide broader solutions. And when we are talking about planning, we understand that planning levels may be numerous, at least more than one, and we are focusing on two quite definite tasks of current planning and strategic planning for logistical chains, for chains of supply, or tactical and strategic. And we see that tactical solutions can be handled by non-simulation mathematical models, but by a digital twin, which can describe the process of the supply chains and can support any decisions for a fixed logistical infrastructure. For example, we can optimize, say, some insurance reserves for a multi-echelon transportation chain, or we may optimize the delivery of cargoes along the chain. Or we can also provide strategic solutions, which quite often are linked to the development or degradation of the supply chains. The infrastructure is never fixed, and we are making decisions about investment. And for example, when we are deciding on investment, and the most common case would be the opening of some new infrastructure like a logistical warehouse, and there we don't need to have a detailed description of the goods that we're going to keep in that warehouse, or very detailed rules of the movement of goods through that warehouse. It just makes the mathematical model too complex and incalculable and very cumbersome. So whenever we're talking about a digital twin, we are really focusing on the main task, the primary task, and together with our clients, we're trying to find the necessary adequate level of aggregation which would meet the model. And this is the purpose of creating such a digital twin of that level. So when we're talking about digital twins, we're not only talking about simulation models, but we're also trying to really optimize the future situation with the minimum costs and the maximum profits that we can get from deploying our solutions or selling our products. Again, when we are talking about CAPEX optimization, we are identifying here some of the main tasks, and we are providing solutions to about 95% of the tasks of our clients. And the most important one would be about closing or opening some new infrastructure. Importantly, companies not only develop and open up a new infrastructure, but they can also close down some of the inefficient infrastructure. And using our digital twin, we can identify the parameters of this new warehouse. So we can use mathematics to try to help the client to understand where to open a warehouse, what size that warehouse should have, and what would be the flow of goods through such a warehouse. And we actually also telling the client how much it is going to cost over the planning horizon. It's one thing to open a warehouse, but it is actually important also to decide when to open it, at which of the planning horizon steps. Usually you have strategies which are reaching out for 10, 20 or even 30 years. And now then the companies need to decide when to really commission a warehouse. And this is important. And this is handled by the digital twin on the strategic level. Another important task that we are frequently facing would be the so-called ideal supply chain. A very interesting exercise, which in the virtual environment, it's good that it is risk-free. We would basically put up all the infrastructure of our client and of the suppliers, and using the digital twin, we can identify where ideally you need to locate your warehouses and whether the existing warehouses are inefficient and cost you money compared to the ideal situation. Now, this is something which is quite in demand, especially in the retail industry, because retail is developing quite intensively, just like the railroads. And then M&A and the synergy from logistics in such M&A deals. And again, quite a popular case that we handle. Also opening up new production lines or defining the ideal split between the third-party transportation and your in-house transportation. Again, something that we can provide a solution for. The digital twins and the information systems that really help to create a digital twin in the definition that I provided before, they fit the IT landscape to optimize the chains of supply. On this slide, you can see the classification by Gartner of the information systems of logistics. When we go from the bottom, from the execution level, that's where we are talking about some inventory, MRP, WMS systems. We go all the way up to the higher level where we already have the ability to plan the cargo flow over the tactical horizon, that is weekly and monthly. And then finally, we are reaching the top of this pyramid of information systems. We come to modeling systems where we can really see all the rules of cargo movement, and we use also solvers to find the best policies and practices of moving the goods through our system. Importantly to say, the cost of ownership, the total cost of ownership of such systems, and we're talking about digital twins, may be by an order less than the ownership of an ERP system. The international experience and the Russian experience shows that you may have hundreds or even thousands of percent as your recovery and as your return on the investment. So it is always economically feasible to have such systems in place. And the overall maturity of the Russian economy is really quite young and low right now in terms of creating digital twins. So those directors that are in charge of the inventories, in charge of the investment policies into supply chains, they most often use two things, their expert opinion and intuition. So our mission, so to say, is to really help use mathematics to take well thought out decisions about supply chains, and that's what we're offering to a large number of Russian companies. Well, there probably I would stop, and if you go to the next slide, it would be wonderful. I'd be happy to take any questions that you may have. Thank you, Dmitry. And the question, well, as far as I understand, you are helping your clients to model their investment programs using the development of the supply chains. Is it like interactive? Is it like a continuous interaction, or is it done from time to time as part of the budget cycle? Or, well, it's a very good question. Thank you for that. And the answer is that since all companies do not live in a vacuum, there are changes happening all the time, but those could be internal and external. And our recommendation is to really reassess and re-examine the investment program based on the rate of such changes. As soon as you have some material changes, take the pandemic, for example, or you have other circumstances, and say many of the outlets have been closed, or say the consumer appetite has changed and the preferences of consumers changed, and you need to somehow adapt to having something new in place. 3 years ago, nobody thought that people would prefer actually to have food and other things to be delivered to their homes rather than going to shops. But this is a fact of life now. Now, large companies are trying to review their investment programs as part of the budget cycle. So annually, such a model should be updated with information about the new demand on goods, about new tariffs, and about some new information of cargo flow. So 3 years ago, probably we actually were using some delivery services, but nobody actually thought that 3 years ago that you would be able to order, say, a particular type of ice cream to be delivered to your home like within 15 minutes. Regarding the experience of Telecom, we discussed that already, but where to do that at the end user's device or in the cloud, or what? We have about 8 minutes left, and I give the floor now to Konstantin Boltrukevich, head of the Department of Systemic Integration of Telecom. Indeed, Telecom is the provider of digital infrastructural services, and our task, as we see it, would be how to make this way of digital transformation as easy and comfortable as possible for our clients and cheap. And of course, we have some expertise accumulated as the general contractor and as the system integrator and supplier and vendor of certain services. So we do see some trends. But what is actually visible today is that the trend for the general cloud solutions would not really be feasible all the time in the case of digital twins, because this infrastructure will have to go down from the cloud to the earth, so that this digital twin would be alive. To give you an example, recently we implemented a project for the integrated stations to receive the rail cars. Now, for the digital twin to exist there, you would need to process about 20 gigabits per second of data so that we can seamlessly provide information about the passage of rail cars. I mean, sending it somewhere to the clouds would not be really optimal or feasible. And hence we need to establish and, create some infrastructure on site. And for companies of smaller size, it would not always be possible. Gazprom Neft or Metalworks or Russian Railways, they already have their own infrastructure. For them, it is not a problem to really deploy those solutions locally. But when we're talking about smaller companies, even smaller railways, it would the determining factor would indeed be the cost of solution. And we found a solution. We had a good case with one of the car repairs company. We actually provided them with a service, with a digital twin, to really monitor the repairs of the wheels, of the rail car wheels, and they also used that data that was partially processed on site, and then it was really sent for the neural networks to handle further. And we provided them with a service, and the client really didn't have any headache about how to set up the local infrastructure and the cloud infrastructure, how where to get the channel of communication, how to optimize the hardware, etc. We actually assumed all that task, and we provided a ready-made solution for the client. And to end, I should say that this approach actually would make it possible to implement the digital twins, and it would be a very accessible and simple solution for a wide range of clients, not only those powerful clients as Russian Railways. Indeed, IoT, you have some industrial IoT, but you have household IoTs where you would use IoT for, irrigating your plants or running your boiler. But in the case of large and complex companies such as Russian Railways, it has always been an issue and question of policy, of infrastructural policy, how we used to live in the past and how we are going to live in the future. And of course, you have some digitalization in place of using microchips instead of relays, but it was in a different era. We were kind of like upgrading from simple mechanical relays to microchips, and we reached that stage. So it was really a federal decision made to implement such technologies. Now we have new trends like we're talking about import substitution, or we are talking about some real-time data handling. So we have a broader choice of technologies, which is a good thing, but it is also a minus because any choice is always difficult. Anyways, thank you, dear panelists, for this very interesting session. I was in your capacity like 3 years ago. I was also one of the panelists, and indeed, it was quite interesting for me. But what I heard today is that we, as the industry, as the country, really made a good progress there. And of course, in IT, you have, a habit of showing pictures and talking about trends, etc. And it is all inspiring. But today we actually provided you with real life experience and examples that are already there by about 90%, and hopefully the rest 10% would be implemented in the next year to come. Thank you very much for taking part in this very interesting and fascinating session, and we would be happy to continue in this format looking forward. Thank you very much.